Monitoring techniques. Transfer tools. Transfer tools such as spring calipers have no reading scale. Jaws on these instruments measure the length, width, or depth in question by positive contact. The dimension measurement is then transferred to another measurement scale for direct reading. Attribute gauges. Attribute gauges are fixed gauges which typically are used to make a go or no-go decision. Examples of attribute instruments are master gauges, plus gauges, contour gauges, thread gauges, limit length gauges, assembly gauges, etc. Attribute data indicates only whether a product is good or bad. Attribute gauges are quick and easy to use, but provide minimal information for production control. Variable gauges. Variable measuring instruments provide a physical measured dimension. Examples of variable instruments are rulers, vernier calipers, micrometers, depth indicators, run-out indicators, etc. Variable information provides a measure of the extent that a product is good or bad relative to specifications. Variable data is often used for process capability determination and may be monitored via control charts. Reference or measuring surfaces. A reference surface is the surface of a measuring tool that is fixed. The measuring surface is movable. Both surfaces must be free from grit or damage, secure to the part, and properly aligned for an accurate measurement. Instrument selection. The terms measuring tool, instrument, and gauge are often used interchangeably in this text. Appropriate gauge should be used for the required measurement. Listed in the following slides are some gauge accuracies and applications. Monitoring techniques. As you can see in the table, the adjustable snap gauges are usually accurate with 10% of the tolerances, and its application is that it measures diameters on a production basis where an exact measurement is needed. The air gauges have an accuracy that depends upon gauge design. Measurements of less than 0.00005 inches are possible. It is used to measure the diameter of a bore or hole. However, other applications are possible. The automatic sorting gauges are accurate within 0.0001 inches and is used to sort parts by dimension. The combination square is accurate within 1 degree and is used to make angular checks. The coordinate measuring machines have accuracy that depends upon the part. Its axis inaccuracies are within 35 millionths and TIR within 0.000005 inches. It can be used to measure a variety of characteristics such as contour, taper, radii, roundness, squareness, etc. The dial bore gauges have accuracy within 0.00001 inch, using great care, and is used to measure bore diameters, tapers, and out of roundness. The dial indicator has an accuracy that depends upon the part. Axis accuracies are within 0.00001 inch and measures a variety of features such as flatness, diameter, concentricity, taper, height, etc. The electronic comparator is accurate from 0.00001 inch to 0.00001 inch and is used where the allowable tolerance is 0.00001 inch or less. The fixed snap gauges has no set accuracy and is normally used to determine if diameters are within specifications. The flush pin gauges have accuracy of about 0.002 inches and is used for high-volume single-purpose applications. The gauge blocks have accuracy that depends upon the grade, and normally the accuracy is 0.000008 inch or better. Gauge blocks are best adapted for precision machining and as a comparison master. The height verniers are mechanical models measured to 0.00001 inch. Some digital models attain 0.000005 inches. They are used to check dimensional tolerances on a surface plate. The internal and external thread gauges cannot provide exact readings. They will discriminate to a given specification limit. They are used for measuring inside and outside pitch thread diameters. The micrometer, inside, has mechanical accuracy of about 0.001 inches. Some digital models are accurate to 0.00005 inches. They are normally used to check diameter or thickness. Special models can check thread diameters. The micrometer outside has mechanical accuracy of about 0.001 inches. Some digital models are accurate to 0.00005 inches. They are normally used to check diameter or thickness. Special models can check thread diameters. The optical comparator has an accuracy that can be within 0.0002 inches. They measure difficult contours and part configurations. The optical flat depending on operator skill and are accurate to a few millionths of an inch. They are used only for very precise tool room work, best used for checking flatness. The plug gauges have accuracy that is very good for checking the largest or smallest hole diameter. They check the diameter of drilled or rimmed holes and will not check for out of roundness. The precision straight edge have visual 0.10 inch with a feeler gauge 0.003 inch and are used to check flatness, waviness, or squareness of a face to a reference plane. The radius and template gauges have accuracy that is no better than 0.015 inches and are used to check small radii and contours. The ring gauges will only discriminate against diameters larger or smaller than the print specification. The best application is to approximate a mating part in assembly, will not check for out of roundness. The split sphere and telescope have no better than 0.00005 inches, using a micrometer graduated in 0.0001 inches, and are used for measuring small hole diameters. The steel ruler or scale are no better than 0.015 inches. They are used to measure heights, depths, diameters, etc. The surface plates have flatness expected to be no better than 0.005 inches between any 2 points. They are used to measure the overall flatness of the object. The tapered parallels are using an accurate micrometer. The accuracy is about 0.005 inches. They are used to measure bore sizes in low-volume applications. The toolmaker's flat has an accuracy that is no better than 0.0005 inches, depending upon the instrument used to measure the height. They are used with a surface plate and gauge blocks to measure height. The vernier calipers are about 0.0001 inches. Some digital models are accurate to 0.00005 inches. They are used to check diameters and thickness. Vernier depth gauge are about 0.001 inches. Some digital models are accurate to 0.00005 inches. They are used to check depths. Attribute screens. Attribute screens are screening tests performed on a sample with the results falling into one of two categories, such as acceptable or not acceptable. Because the screen tests are conducted on either the entire population of items or on a significantly large proportion of the population, the screen test must be of a non-destructive nature. Screening programs have the following characteristics: a clearly defined purpose, high sensitivity to the attribute being measured, that is, a low false negative rate, high specificity to the attribute being measured, that is, a low false positive rate. Benefits of the program outweigh the costs. Measured attributes identify major problems, that is, serious and common. Results lead to useful actions. Common applications of screening tests occur in reliability assessments and in the medical screening of individuals. In reliability assessments, an attribute screen test may be conducted to separate production units that are susceptible to high initial failure rates. This period is also known as the infant mortality period. The test simulates a customer use of the unit, or perhaps an accelerated condition of use. The number of failures per unit of time is monitored, and the screen test continues until the failure rate has reached an acceptable level. The screen test separates acceptable items from failed items, and an analysis of the failed components is performed to find the cause of the failure. In medical screening, a specific symptom or condition is targeted, and members of a defined population are selected for evaluation. Examples of this type of screening include a specific type of cancer or a specific disease. In many cases, the members of the selected population may not be aware that they have the condition being screened. Medical screening tests have the ultimate objective of saving lives. Tool care. Measuring instruments are typically expensive and should be treated with care to preserve their accuracy and longevity. Some instruments require storage in a customized case or controlled environment when not in use. Even sturdy hand tools are susceptible to wear and damage. Hardened steel tools require a light film of oil to prevent rusting. Care must be taken in the application of oil, since dust particles will cause buildup on the gauge's functional surfaces. Measuring tools must be calibrated on a scheduled basis as well as after any suspected damage. Gauge blocks. Near the beginning of the 20th century, Carl Johansson of Sweden developed steel blocks to an accuracy believed impossible by many others at the time. His objective was to establish a measurement standard that not only would duplicate national standards, but also could be used in any shop. He was able to build gauge blocks to an accuracy within a few millionths of an inch. When first introduced, Gauge blocks, or Joe blocks as they are popularly known in the shop, were a great novelty. Seldom used for measurements, they were kept locked up and were only brought out to impress visitors. Today, gauge blocks are used in almost every shop manufacturing a product requiring mechanical inspection. They are used to set a length dimension for a transfer measurement and for calibration of a number of other tools. We generally distinguish three basic gauge block forms: rectangular, square, and round. The rectangular and square varieties are in much wider use. Generally, gauge blocks are made from high-carbon or chromium alloyed steel. Tungsten carbide, chromium carbide, and fused quartz are also used. All gauge blocks are manufactured with tight tolerances on flatness, parallelism, and surface smoothness. Gauge blocks should always be handled on the non-polished sides. Blocks should be cleaned prior to stacking with filtered kerosene, benzene, or carbon tetrachloride. A soft, clean cloth or chamois should be used. A light residual oil film must remain on blocks for ringing purposes. Block stacks are assembled by a ringing process which attaches the blocks by a combination of molecular attraction and the adhesive effect of a very thin oil film. Air between the block boundaries is squeezed out. The sequential steps for the ringing of rectangular blocks is shown below. Light pressure is used throughout the process. As you can see in the table, the U.S. Federal Accuracy Standard Gauge block grades have new designations and old designations and have appropriate accuracy in length. The old designation of AAA has a new designation of 0.5 and an accuracy of plus or minus 0.00001. The old designation of AA has a new designation of 1 and an accuracy of plus or minus 0.000002. The old designation of A+ has a new designation of 2 and an accuracy of plus 0.000004 and minus 0.000002. The old designation of A and B has a new designation of 3 and an accuracy of plus 0.000008 and minus 0.00004.